Okay, we continue with chapter 3. So one of the curve is, empirical rule. And for the data set having a distribution that is approximately bell shape, what it is with empirical rule, he has done some study and he's saying that 68% of all the value always fall one standard deviation, 95 two standard deviation, and three standard deviation 99.7. So you see, this is a study that he has done. Because normally when you have a bell-shaped curve, if you actually get close to the tails, these where the critical areas are, okay? So when you create some histogram here and you draw your bell shape, this is a good area which normally is usual. If the value falls here, the usual. But if the value normally falls beyond mean plus 2 standard deviation or mean minus 2 standard deviation, then it's not good, then it's unusual. So empirical rule, he has done a study and he proved that 95% of data always fall between mean plus 2 standard deviation and mean minus 2 standard deviation. Okay, that's all it is with empirical rule. So he shows that 34% of the data and 34% on this one is always between mean minus standard deviation and mean plus standard deviation. You see, normally when you go beyond mean plus 2 standard deviation is the critical zone. So what it is, we will have some example in the near future, you see it. We give you the mean, sample mean, we give you a standard deviation. You take the standard deviation of the sample, multiply by 2, plus the mean, and you also subtract from the mean. That gives you two numbers. Those two numbers are your border points. So if we give you a number in the problem, say, is this usual or unusual? You got to see if that number falls beyond mean plus 2 standard or below mean minus 2 standard deviation. Then you say it's unusual. These are all about empirical rule. See, like this example. In this example, they give you the IQ score of the bell-shaped distribution. They are saying that mean is 100 and the standard deviation is 15. See, mean and standard deviations are given. So you take that, you take the standard deviation, you multiply that by 2, and then you add and subtract from your mean. These two numbers are those two numbers that I tell you is the border points. And if you go beyond or below that, it's unusual. Okay, so we always try to create two numbers from mean plus or minus 2 standard deviations. And Chebyshev theory, he also has done some study and he said that he does it based on mean plus 3 plus or minus a standard deviation. He said the three-quarter of data is between 2. So this is a study by him. And then I put some example here for you. Like, again, this example is about empirical rule. We give you standard deviations. And then this one, we are asking you to take that standard deviation and the mean. You do that, then you create these two numbers, okay? And these two numbers are mean plus or minus 2s. See, this is examples that you kind of exaggerate. We want to show you when do we fall into critical area or not. This is an example of a couple want to have 20 children, right? It just we exaggerate so you could see something better. What's the probability of none of the children, none of the 20 is a girl? 0. One of the probability, just 1 out of 20 is a girl. So probably getting a little better. What's the probability of 2 out of 20 is girl? Probably keep increasing. What's the probability that half of the children are girls? Very good, 0.18. So this 0.18 is the top one. And then when you go beyond this, what's the probability of 11 children are girls, 12 children, 13, 14? What's the probability of all 20 are girls? or none is girls, you know, so they fall onto 0. So this is a very good bar graph that is symmetric. And when I connect all the points together, then you see a bell shape. So there are places here that is unusual. Like, is it unusual to have 18 girls out of 20, or it is usual to have 3 out of 20? Those are the points that fall here, which is unusual. So you create your table first, then you have your graph, and then you find these 2 critical points. This is unusual. So if your number fall beyond or below these 2 numbers, then you say those numbers are unusual. Okay. See, in this case, mean plus 2 standard deviation is almost 14, and the other one is almost 6. So any number beyond 14 or less than 5 is unusual. Like, what's the probability of 14 out of 20 are the girls? 14 and above is unusual. What's the probability of 4 out of 20 are the girls, or 3? See, this is very low. These are unusual sections. They call it critical zone. And when you connect it, you see a graph like this, you know? See, this point is X is mean plus 2 sample, 2 standard deviation. This is mean minus 2 standard deviation. Another, it was a bar graph, and then you connect the top. So you have a different kind, symmetric, skewed. Like you have one is the completely symmetric. You have one which is skewed to the right. See, which is the bar graph is all like that. Look. Or you have one which tails is to the left. Like that. It's skewed to the left, it's skewed to the right, and it's very, very symmetric. Symmetric shape, bell shape, is skewed to the right, skewed to the left. These are all definitions. What is a skewed to the left? What is a skewed to the right? Shape of distributions. See, we have a better pictures here. See, this is a skew to the right. See, it's skewed to the right. This is skewed to the left. I think on the other page I said it backwards. When it's completely symmetric, then mode, mean, and median, they all fall in the middle. The other thing we want to discuss is a z-score. What is z-score? These are the formula, whether you have populations or sample, it doesn't matter. Both formula are the same thing. It depends what you have in the problems. So let's say you have this. In the problems, when you do the calculation for the z, if z fall between 2 and -2, then this is an ordinary values number. If you go beyond 2 or below -2 is unusual value. All right, so I think when you see this example, you understand where we use the z. See, in this example, we want to compare height of the president with athletic and basketball player, right? With a height of 75 inch, Lyndon Johnson was the tallest president of the past century. And on the other hand, we have Shaquille, whose height is 70, let's see, what's this? President is this, and Shaquille is 80. Just because Shaquille is 80 and president is 75 inch, we cannot compare these two and say, well, Shaquille is taller. No. What you need to do, since they're both coming from 2 different populations, one is population of president, one population of basketball players, what you need to do is do the conversion to bring both to the same scale. That's the formula that we use. So first for Lyndon Johnson, we understand that the mean and the standard deviation for all the presidents are given in the problems, 71.5 and 2.1. And Shakil's is 75H. So when we calculate the Z for, for Lyndon Johnson for president, when we calculate it for Lyndon Johnson, it's 1.67. However, when we do the calculation for Shakil, it's 1.52. See, Z of President Lyndon Johnson is larger than Shakil O'Neal. Then we say President is relatively taller than basketball player Shakil O'Neal. Okay, so again, this is where do we use the Z? When you want to compare two items from different populations, you have to bring them to the same scale and then do the comparison. And this is a formula to do for that. And these are some examples, you know, like if you want to know, this is a good example to show which one is it accounting and marketing, two different fields you want to compare. This is, I put another example for you for SAT test and SAT test. You know, you have to do the conversion first, and then when you find the numbers, and then you understand on the number line, see on the number line, minus 0.85 is here, and minus 0.09 is here on the number line, right? So minus 0.09 is larger than minus 0.85 on the number line. So, and that happened to be for SAT, so SAT is better than SAT. See, this is another example you could read, and if you have any questions, you could ask me. Just comparing where do we use it in the, you know, we use it often in different industries like insurance. They use this formula. Next is how to do the percentage. If you take a straight line and divide it into 100 pieces, each piece is 1%. We call it percentile. There are formula that if we ask you to find a percentile, you take the number of value less than X, divide by total number, multiply by 100. You could take a straight line and divide it into 4 equal pieces. See, you could take it, look, you could take a straight line and divide it into 4 equal pieces. This is a minimum number, this is a maximum number, 25%, 50%, and 75%. So when we ask you to calculate Q1, Q2, Q3, means we want you to take all the numbers divided by 4 sections and then read those. So this is the examples. See, we are using 2 formulas. One is for you to calculate the percentile. Means there is a number, we want to know that number, what percentile is for that number. For instance, 213. 213 is here, okay? Is 4th number. Percentile is how many numbers are less than that. Like if you want to calculate for 213, how many numbers are before 213? 1, 2, 3. You put that 3 here. Total number of values. Total number of values, there are 25 of them. You just put it here, multiply that by 100, okay? So let's say here, I want to find the percentile of 213, right? I want to see on the whole thing, when you list all your numbers here, 213, what is the percentile of 213? What is the percentile of 213? How many numbers are before this? 1, 2, 3, okay? So that would be 3. How many numbers do we have altogether? 25, and then you multiply always that by 100. So it would be 300 divided by 25. That gives you the percentile. That's what it is here. Okay, so let's say we want to find percentile of 240. 240 is right here. How many numbers are before 240? 1, 2, 3, 4, 5, 6, 7, 8. So it would be 8 times 100 divided by, there are 25 numbers. So it's 800 divided by 25, whatever that is the percentage. And you see the calculations on that. The next is the formula. This formula we use when you have a percentile and you want to find the number. Okay, so in that case, we use this formula. N is 25. There are only 25 numbers, so that the number doesn't change. It's the K is change. Okay, K is the percentile. K is the percentile given. So here is L is K N over 100. And we know N is 25. So 25K divided by 100. Let's say you want to find what is the percentile of 60. You take that 60 and you put it here, so L would be that. Okay? Which is 15. Now, the thing is, this is very important here. If your number is the whole number, it doesn't mean that you should start look for number 15. You should not say, okay, I came up with 15, right? It's a whole number. I shouldn't say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is the number. No. If it's the whole number, you always take the average of that number and one after. So here, I have to take an average of number 15 and 16, average of these two. Which one of this is 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is 251, and 16 is 252. So you take the average of these two. Average of 251 plus 252 divided by 2, something like that. 251 plus 252 divided by 2. If your number is a whole number, if your number is decimal number, you always round it up. See? So this is the solution for these problems. See how the number for this one, the number is whole number, is 12, right? That doesn't mean that go ahead and pick the number that location is 12. You have to find that number and the one after, and then take the average. So that would be a percentile. And then there are some examples of percentile here. And any of these examples, if you have a question. See, we have a term, they call it interquartile. Interquartile range means Q3 minus Q1, or IQR. When we ask you to find IQR, IQR means Q3 minus Q1. 5-number summary. We use this for the box plot, okay? Box plot is a graph of data set consists of a line extending from minimum value to the maximum value. And the box is we draw with a Q1, Q2, Q3. Look, this is a box plot. When we ask you to graph the box plot, there are 5 numbers on it. Minimum number, maximum number, and then Q1, Q2, Q3, you have to calculate that. Q2 is always the median, okay? So on the percentile, we show you how to calculate Q1 and Q3. So when you graph the box plot, that tells you that this is like this. It's kind of symmetric shape. See, all the data are concentrated in the center here. So this is kind of, if I want to graph this one, it would be something like this. See, it's very good bell shape here. That's what it is. This one is all the data has come to the left. You see that? So the shape of this one probably is like this. See? Most of the data are here. So these are all examples of the box plot. And then we have modify, outlier and modify box plot. Modify box plot, again, you read the examples here. Sometimes if there is an outlier, you want to modify your box plot. If there is an outlier, you read all this literature and compare to that. I'll put it here for you. Okay, so look, we have all these numbers, right? So they ask us to construct a box plot. So first you write all the numbers in order from smallest to the largest. Then we need to calculate the median. Median are these odds or number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So what number is exactly in the middle? You find that one. 1, 2, 3, 4, 5. See, it's this one. Okay? So 51 is your median because the numbers are odd. Then the smallest value is 2. Largest value is 3, 63. And you find your Q1, Q3, IQR, which is Q3 minus Q1. Then you find 1.5 times that, 16.5. To find those two numbers that you, for modified box, these are just for modified box plots, you have to find Q1 minus 1.5 IQR. Q1, we already know it's 49, 1.5 IQR, we have that. These two numbers, you see here with the yellow, you get it, stop your box plot right here. When you do that, that means this number 2 is an outlier. This 2 is an outlier. But modified box plot normally is used to eliminate the outlier. To find the outlier, this is the way to do it. See, we cut it right here. So don't take any number between beyond 76.5 or less than 32.5. We don't have anything here, but we have one number here, so that would be your outlier. See here in these problems, when we do all these, we find a modify. The modify is these two. You put your minimum, you put your maximum, you put all Q1, Q2, Q3. This one is not modified box plot, it's just a box plot. So in order to graph your box plot, you need 5 numbers. You need your minimum, you need your maximum, you need the Q1, Q2, and Q3, and then you graph a rectangle here. That's an indication of box plot. See all this? Okay? So that's another modify. It just shows that you have to erase the graph from here. So that would be end of chapter 3. So please read the document and study the video and let me know if you have any questions.